welcome back to today's Vidyanagar online science class. And I'm here with you to continue our chapter Magnetic Effects of Electric Current. And in today's class, we are going to discuss about electric motor. We are going to discuss about electric motor in our today's class. Shall we begin? Okay. So first we have to know what is an electric motor. Electric motor is a rotating device which converts electric energy to mechanical energy. Electric motor is a rotating device that converts electrical energy to mechanical energy. So it's a device which converts electrical energy to mechanical energy, which means by giving electricity, the machines rotate, right? So what part inside these machines? That machines contain electric motor. So what is an electric motor? Electric motor is a device, or it's a rotating device that convert electrical energy to mechanical energy. So simply you can define electric motor is a device which converts electrical energy into mechanical energy. Electricity converts to mechanical energy. By passing electricity, we can rotate the machineries, or there will be some actions like rotation of the fan and working of the washing machine, etc. So electric motor is a device. It's a rotating device that converts electricity to mechanical energy. So electric motor is a rotating device which converts electrical energy into mechanical energy. It's a device which converts electrical energy to mechanical energy. So keep it in your mind, electricity to mechanical energy. So electric motor is a device which converts electrical energy into mechanical energy. Okay, and electric motors are used as the main components in electric fan, washing machine, refrigerator, mixie, etc. So in these equipments contains electric motor as the main components. So electric motor is a rotating device which converts electrical energy into mechanical energy, and these motors are used in electric fan, mixie, refrigerator, washing machine, etc. Okay, so before describing about the electric motor, you have to know the principle behind this. Which principle is used in electric motor? So the principle for the electric motor is that a current carrying coil is placed in a magnetic field. It experiences a force, which means when two magnets are near to each other, they experience a force. So that is the basic principle of electric motor. So what is the principle of electric motor? A current carrying coil placed in a magnetic field experience a force. A current carrying coil means electromagnet, or when two magnets are near to each other, they experience a force. So that is the principle of electric motor. A current carrying coil placed in a magnetic field experience a force, or when two magnets are near to each other, they experience a force. Okay, so that is the principle of electric motor. Electric motor is a device which converts electrical energy into mechanical energy, and the principle of electric motor is that when two magnets are near to each other, it experiences a force. So in the correct way, when a current carrying coil placed in a magnetic field experiences a force, or two magnets near to each other that experience a force. Okay, so now we can discuss about the parts of electric motor. What are the parts for an electric motor? See, a rectangular coil ABCD, a rectangular coil ABCD present in an electric motor. So an electric motor consists of a rectangular coil A, B, C, D of an insulated copper wire. So which is the first part of electric motor? A rectangular coil ABCD of an insulated copper wire. So the other name for this rectangular coil is armature. Armature. What is the other name of rectangular coil? Armature. So you can generally use the rectangular coil, and there is one more name for this, that is armature. So an electric motor consists of a rectangular coil ABCD of an insulated copper wire, or a motor contains armature coil ABCD. So the first part of the electric motor in a rectangular coil ABCD, and this rectangular coil is placed between the poles of the magnet. So this coil is placed in between the poles of the magnet, and this coil is placed between the poles of the magnet. So the first line, an electric motor consists of a rectangular coil ABCD or an armature coil ABCD, and this coil is placed between the poles of the magnet. Placed between the poles of the magnet in such a way that arm AB and arm CD are perpendicular to the direction of magnetic field. So that is very important, right? So this coil is placed between the poles of the magnet. So the armature coil ABCD is placed between the poles of the magnet in such a way that arm AB and arm CD perpendicular to the direction of magnetic field. So this is arm AB and arm CD. So the coil is placed in such a way that arm AB and CD are perpendicular to the direction of magnetic field. That's the second line. And the third line, the ends of the end of the coil is connected to the two halves P and Q. So you can see two halves P and Q, two half rings, right? You can see two half rings P and Q. So the ends of the coil is connected to the halves P and Q. Got it? So the ends of the coil is connected to the two halves P and Q. These two halves, right? P and Q, two half rings. You can see two half rings, and the ends of the coil is connected to the two halves P and Q, and the inner side of the coil is insulated. The inner side of the halves, the inner side of these halves are insulated and attached to an axle. So you can see one pipe like thing. So that is axle. What is this? Axle. Axle. Okay, so the end of the coil is connected to the two halves P and Q. The inner side of the halves are insulated and attached to an axle O. Attached to an axle O. So this is the parts. What are the parts? A coil ABCD, an armature coil ABCD placed between the poles of the magnet. A rectangular coil ABCD is placed between the poles of the magnet in such a way that arm AB and CD are perpendicular to the direction of magnetic field. Then the end of the coil is connected to the two halves P and Q. The end of the coil is connected to the two halves P and Q. The inner side of this coil are insulated and it is attached to an axle. Okay, then you can see the remaining section is the circuit. You can see the end on battery and key. So circuit, now this become a complete circuit, and when we plug the key, it starts to work, right? So which are the parts? Okay, what is the principle? When two magnet, you can see magnet, and when electricity flows through the coil, this also behaves like a magnet. So when two magnets near to each other, they experience a force. That is a principle of electric motor. A current carrying coil placed in a magnetic field experience a force, or when two magnets near to each other, they experience a force. That is the principle of electric motor. An electric motor is a device which converts electrical energy into mechanical energy. And what are the parts of an electric motor? An electric motor consists of a rectangular coil ABCD or armature coil ABCD, and this coil is placed between the poles of the magnet, and the ends of the coil is connected to the two halves P and Q. Okay, so these are two halves and the name of these halves are split rings, and the use of split rings we will discuss at the last of this, it's working, right? So what is the name of these halves? Split rings. So the two halves P and Q, and its name split rings. Split rings. Okay, so the two ends of the coil is connected to the split rings P and Q. So two ends of the coil is connected to the two halves P and Q of a split rings, and the inner side of the halves are insulated and it is attached to an axle, and you can see two brushes X and Y, X, and there is two stationary brushes on the halves P and Q. Okay, that also very important, right? So the two, you can see the two halves, and inner side of these halves are insulated and it is attached to an axle, and on the halves you can see two brushes, brush X and Y. They are stationary brushes. Stationary brushes means not moving. Okay, so there is two stationary brush X and Y pressed on the halves P and Q. Okay, so once again the parts, the coil ABCD placed between the poles of the magnet. The two ends of the coil is connected to the two halves P and Q of the split rings, and the inner side of these halves are insulated and it is attached to an axle, and two conducting brushes X and Y attached on the halves P and Q. So coil ABCD, ends of the coil is connected to the two halves, and the inner side of these halves are insulated and it is attached to an axle, and there is two stationary brushes attached on the halves P and Q. Okay, so this is about the parts of the electric motor. What is another name of the rectangular coil? Armature, and the name of the halves? Split rings. Okay, then the remaining section is the circuit, right? Remaining section is the circuit. On plugging the key, now this became a closed circuit, right? On plugging the key, electricity starts to flow through that, right? So by using that electricity, the motor starts to work, right? That means rotates. So that is the exact point of this electric motor. We will supply the electricity, and when we supply the electricity, the coil behaves like a magnet. When two magnets near to each other, they experience a force. Due to that force, the motor starts to rotate. So first we supplied the electricity, then later the motor starts to rotate. Rotation of the motor means mechanics, movement, mechanics. So electricity changes to mechanical energy. Rotation means mechanical energy. So we supplied the electricity, using that electricity, the motor starts to rotate. So rotation of the motor indicates it's the formation of mechanical energy. So it's a device which converts electrical energy into mechanical energy. Okay, so on plugging the key, the electricity starts to flow through it. Okay, so the another point you have to understand that on plugging the key, the current flows through the brush X. On plugging the key, the current from the battery flows through the brush X, and through this, it flows back to the brush Y. So it enters to the coil through the brush X and it flows back to the circuit through the brush Y. So very important, right? So on plugging the key, electricity or the current flows through the brush X and it flows back through the brush Y. So through the brush X, the electricity enters to the coil, and through the brush Y, it comes back to the circuit. So the current flows through the brush X and it flows back through the brush Y. So it enters through the brush X and it comes out of the coil through the brush Y. Okay, another point, the direction of the current on arm AB. So this is arm AB. So the direction of the current on arm AB from A to B. See the direction, the arrow is up. Upward arrow indicates the current flows through the arm AB to upward direction. So the direction of the current on arm AB is upward, means A to B. And what about arm CD? It is downward arrow. Downward arrow means it is C to D. So the direction of current on arm AB, it is A to B, and on arm CD it is C to D. Means just opposite to each other. So on arm AB the current flows through A to B, and on arm CD it is C to D. So just opposite to each other. So the direction of the current on arm AB to up, that is A to B, and on CD it is down, that is C to D, downward, just opposite to each other. So on arm AB the direction of current A to B, and on arm CD it is C to D. Okay. Then another very important point. On passing the electricity, the coil behaves like a magnet, right? The coil behaves like a magnet. And when two magnets are near to each other, they experience a force, which means on arm AB and on arm AD, there is application of the force, but in arm, in these two ends, here and here, there is no application of the force, because here you consider they are parallel to the magnetic field. So that we discussed in the previous class, when these are perpendicular to each other, there is the application or exertion of the force. When they are parallel to each other, there is no force. So you don't think more, just consider here and here there is no formation of force, because in these two ends they are parallel to the magnetic field. So you don't think more, there the magnetic field is parallel to each other, but only the force application on these two arms. So we will repeat the arms AB and CD repeatedly. Okay, so don't think more. Here and here you don't consider anything, there is no force, only our actions on these two arms. Why? Because here and here they are parallel to the magnetic field. Okay, if they are parallel to the magnetic field, there is no force. So on arm AB and on arm CD there is an exertion of force, right? So the force exerted on arm AB, the force on arm AB pushes it downwards, and the force on arm CD pushes it upward. The force on the arm AB pushes it downwards, and the force on arm CD pushes it upward. Consider a coil, just consider this is a rectangular coil ABCD, A, B, C, D, A, B, C, D. So I told you on these arms there is an exertion of force. So the force act on arm AB pushes it downwards. So this arm pushes it down, and at the same time the force on arm CD pushes it upward. So this is the coil A, B, C, D. The force on arm AB pushes it down. So this is that action. Okay, this is arm AB. So it pushes down, and at the same time the arm CD pushes it up. So how the rotation? Rotation is like this. See? You just carefully observe the rotation. AB pushes it downward and CD pushes it upward. So the rotation will be like this. That means the coil ABCD rotated anti-clockwise. The coil ABCD rotated anti-clockwise. Have you got it, the point? So the arm AB pushes it downward. Arm AB and CD pushes up and AB pushes down. So on rotation, at half rotation, what happens? AB pushes it down and CD pushes it up. So the rotation will be like this. So now one rotation is over. Right. So you just consider which is this arm now. This is DC and this is BA, right? Or AB and CD. This is AB and this is CD. Right. So at the first part, arm AB pushes it down and arm CD pushes it upward. So the rotation will be like this. Which means the coil rotated anti-clockwise, and now the direction of current in the coil is from, you see, DCBA. DCBA. Okay. So the arm AB, consider this is arm AB. Right. So arm AB pushes it down and arm CD pushes it up. Okay. So the rotation will be like this. Okay. So now this is, see, D, C, A, B. And at that time, is anything happens to the brush? Brush will not move its position. Why? Because it's a stationary brush. Right. But there is change in the position of these halves, P and Q. You can see the changes for the P and Q. There is no change for the X and Y. Okay. So when the coil is in A, B, C, D, the brush X is contact with the half P and Q in contact with the Y. So after half rotation, now it is, it's just opposite. See, now the CD in the place of AB and AB in the position place of CD. DCBA. So at that time, so this is X and Y. Now this is Q and P. Now the brush X in contact with the half Q and the brush Y in contact with the brush with the half P, because it's changed, right? Which means now the direction of current, from D, this is the direction of current. So in the previous case, the current on arm AB, A to B, up. Now you see, in current on arm A, DC, the current is from D to C, up, and here it is A to B, down. So now on arm CD, the direction of current from D to C, upward, right? Here it is B to A, downward. So earlier it was A to B and C to D. Now it is changed, D to C and B to A, which means in the previous case, P in contact with the brush X and Y in contact with the brush Q. Now the brush X in contact with the half Q and Y in contact with the P. Why? Because rotation, one rotation over now. Got it? So, on arm AB, on the force exerted on arm AB pushes it downward, arm AB and CD. So the force exerted on arm AB pushes it downward, and on arm CD it is pushes it upward, right? So the rotation is like this. So now one rotation is over. So after half rotation, the direction of the current is from DCBA. At the same time, the brush X in contact with the half Q and Y in contact with P. Earlier it was, P in contact with X and Y in contact with the Q. At that time, the direction of current is from A, B, C, D. But now it is D, C, B, A, because the direction of the current changed. Why the direction of current changed? So that is due to the split rings. These split rings reverses the direction of current. What is the role of split ring in the electric motor? These split rings are reversing the direction of current, so they are commutators, split ring commutators. So what is the role of split ring commutators in the electric motor? These split ring commutators reverse the direction of current. So at the beginning, the flow of current from ABCD, and after the half rotation, the direction changed to DCBA. So at that time, the brush X in contact with Q and Y in contact with the P. But earlier it was, the direction of current is ABCD. At that time, brush X in contact with the P and Y in contact with the Q. Okay, so on the force on the arm AB pushes it downward and CD pushes it upward. So the direction of the current changed to DCBA. Earlier it was ABCD. At that time, the X in contact with the Q and Y in contact with the P. And the commutator or the split rings reverses the direction of current. So this rotation will, continuously happens. So the motor works. The rotation, it will be like this. Okay, first this is ABCD. Now DCBA, then again ABCD. Okay, then DCBA, again ABCD. So it continues like this. So that is rotation. Got it? Okay, so which are the parts? A rectangular coil ABCD is placed between the poles of the magnet. So the two ends of the coil is connected to the two halves P and Q, and the inner side of these halves are insulated and attached to an axle, and there is a stationary brushes X and Y attached on the halves, and these the halves are split rings, and another name of the coil is armature. Okay, and on plugging the key, electricity starts to flow through the circuit, and the current from the battery through the brush X, it enters to the coil and flows back to the circuit through the brush Y. So it enters through X and returns through the brush Y. And on arm AB, the direction of current is from A to B, and on CD it is C to D, just opposite to each other. Okay, and when two magnets are near to each other, they experience a force. That is the principle of electric motor. A current carrying coil placed in a magnetic field experience a force. So that's the principle of electric motor. So when these two magnets are near to each other, they experience a force. That force helps in the rotation of electric motor. Okay, so the force exerted on arm AB pushes it downward, and on arm CD pushes it upward, which means the coil rotates anti-clockwise. Okay, so how that rotation? Consider this is the coil. So on arm AB pushes it downward and CD pushes it upward. So the direction of the current changed to DCBA. So earlier it was, now, and in this case it is the direction of current is from A, B, C, D. A, B, C, D. At that time, what is the position of the brushes? The P in contact with X and Q in contact with Y. And after plugging the key, the electricity starts to flow through the circuit, and the force exerted on arm AB pushes it downward and CD pushes it upward, and after half rotation, the direction of the current from DCBA. At that time, the brush X in contact with Q and Y in contact with the P. So the direction of the current is from DCBA. So the split ring reverses the direction of the current. So it is also known as commutator. So the use of or the role of split ring commutators in the electric motor, it reverses the direction of current. So this reversion of the current occurs continuously. See, now this is DCBA. So after half rotation, A, B, C, D. So how it will explain? So now the current is DCBA. Okay. So after half rotation, the arm, which arm is this? This is CD and this is AB. So arm AB, earlier it pushed up. So the arm AB, earlier it was pushed upwards, now pushed down. So the arm CD pushed upward in the first part, now it pushed downward. CD pushed downward and AB pushed upward. So after half rotation, the direction of the current is from AB, CD. At that time, the brush X in contact with the P and brush Y in contact with the Q. Okay, so now this is ABCD, then same, AB pushes it down and CD pushes it up. So the direction of the current DCBA. Then again, so it rotates continuously. Okay, so the reversal of the current is due to the presence of split ring commutator, and the split ring commutator reverses the direction of current. Okay, so this is the working of electric motor. When we pass electricity, the two arms exert force in the opposite direction. Due to that application of the force, the coil rotates continuously. Due to the rotation of the coil, the equipment works. Now we can discuss how can we increase the speed of electric motor. We can increase the speed of electric motor by increasing the strength of the current. First one, increasing the strength of the current. Increasing the strength of the current increases the strength of the magnetic field, so it increases the speed of motor. So the first point is increasing the strength of the current. Second one, increasing the number of coils. If you use some more coils, the current through each coil adds up and it gives a big current. If the current is big, it produces strong magnetic field and it increases the speed of the electric motor. And the third one, increasing the area of the coil. And the last one, increasing the strength of the magnetic field. So how can we increase the speed of an electric motor? By increasing the strength of the current. Increasing strength increases the speed of electric motor. Then increasing number of turns also increases the speed of electric motor. Then third one, increasing the area of the coil, and the last one, increasing the strength of the magnetic field. So these factors increases the speed of current, increase speed of electric motor, and they are increasing the strength of the current, increasing the number of coils, and increasing the area of the coil, and increasing the strength of the magnetic field. Okay, so electric motor is the device which converts electrical energy into mechanical energy, and the principle of electric motor is a current carrying coil in a magnetic field experience a force. Okay, and the parts of the electric motor are armature coil, split rings, brush, then it's key, battery, etc. And when two magnets near to each other, they experience a force, and there is an exertion of force on two arms AB and CD, and these AB and CD exert force. Due to that exertion of force, the coil rotates, and alternatively it changes the direction of current due to the presence of split rings. Okay, so that's all about today's class. Okay, we will meet you soon with another video. Till then, it's bye. Thank you for watching.